So today we will go through lecture number 10, and in lecture number 9 we have discussed the direct design method. That was part 1, where we have calculated the total design moment based on Indian Standard 456 guidelines, and then we have distributed the total design moment into negative moment as well as positive bending moment, and that was the calculation for a span, or you can say or a panel of a flat slab. Now let us recall it so that we can understand what is will be in today's lecture. Now, in earlier section, in the last lecture, we have gone through all the details, that mean how to calculate design moment M0 in a panel and how to distribute into negative and positive value in longitudinal direction as per the given clause. So this is an exterior panel and there is interior panel, and in between supports are there. So accordingly we have distributed. So this will be the longitudinal direction of the slab, and total moment which we have calculated M0, that is distributed as negative as well as positive. So according to the type of span, whether it is exterior span or whether it is interior span, in interior span we have distributed that total moment into positive and negative as per all the details which we have already discussed. That means separately for if the case is of interior span or if the case is of end span. So today we will be switching over to the next version of the problem. That means we will be redistributing. Now here we have distributed, that means first distribution of total design moment into negative and positive. Now we will be redistributing, that means this negative and positive moment which we have calculated here in longitudinal direction, that will be redistributed as per the codal guidelines towards the transverse direction. Now this will be redistribution of negative and positive moment which we have obtained in earlier step. In the previous step we have to refer clause number 31.5.5. Now this negative and positive bending moment is redistributed in the transverse direction, that means in the direction perpendicular to the direction in the longitudinal direction, that is along the width of the panel. Now we have to redistribute this negative and positive bending moment along the width of the panel into column strip and half of the middle strip. So this will be the table which we obtained with the help of IS 456 recommendations. So first of all, in the first column we have to list out movement to distribute, that means whether it is negative movement or whether it is positive movement, and depending upon the guideline mentioned in the code, second column will be column or wall width. So there will be some condition we will be able to understand, and third column is percentage of movement at that support. That means whatever be the negative movement available in the first column, then how much percentage of that will be distributed at different supports. So let us go through the diagram carefully. Now this is the whole diagram of the portion of a flat slab, and if you go through it minutely, so this is the exterior column and this one is the interior column, and along this side the slab is continue, even along this side slab is continue. So this was the diagram which we have already discussed in lecture number 9. Now we have divided this portion, that means this panel is divided into column strip in which columns are located, and half strip, that is the half middle strip of one side and half middle strip of second side. So that means in this whole panel we have to redistribute the movement negative as well as positive, which depends upon whether it is exterior span or whether it is interior span. And here this will be the end span or exterior span, and beyond this, beyond the interior column, there will be the interior span. So we have to carefully understand all the concept to avoid any type of misconception. Now here BCS is the width of the column strip, and BHMS, that means half middle strip. This is the width of half middle strip. This is the width of half middle strip. Now how to redistribute? To understand it clearly, first of all we discuss negative moment. That means we have to redistribute negative moment which we obtained in the previous lecture. So this negative moment, if there is an interior span, so this one will be the interior span where cursor is moving, then how to distribute? So interior span, 75% of the movement will be distributed, or you can say redistributed, to column strip. That means column strip will be designed for 75% of the negative bending moment, which can be seen here. So this will be the 75% of M0 is design moment and negative for negative moment. That means we have already distributed design moment M0 into M0 negative as well as M0 positive. Now INT here for internal, that means it is the interior span. So 75% will be distributed in the column strip, and 25% remaining will be distributed into half the middle strip. That means this half middle strip and this half middle strip, they will both share total 25% of the negative movement. So total 25, if we divide it into two parts, then it will be 0.125, that means 12.5% of negative movement. So this is the way how to distribute negative movement if there is interior span. Now redistribution of negative movement if there is end span. If you are designing the end span, then how to redistribute? Now here you have to check whether your column width is less than 0.75 of L2 of span length. If this condition fulfills, then 100% of the negative moment will be distributed to the column strip, or you can say that column strip of the end span will be designed for 100% of this negative moment, which we have already calculated if this condition fulfilled, which you can easily see here. This is the 100%, and no movement, negative movement, will be redistributed to the middle strip. So if this condition fulfill. Now if this condition don't fulfill, that means another condition, if it is greater than, if the column width is greater than 0.75 L2, then what we have to do, we have to multiply movement at support by BCS by L2. That means whatever be the movement here, you have to multiply it by BCS by L2. Accordingly, whatever be the remaining movement, that you have to redistribute into the both the half middle strips. So this is the way how to redistribute negative movement in interior span as well as negative movement in end span. So third condition, positive movement. How to distribute positive movement in all type of spans. So 60% of the positive movement will be redistributed to the column strip. You can easily see here to understand that 60% of the movement is redistributed and 20% 20% in each half middle strip. That means remaining 40% will be equally redistributed, 20% and 20% in both the half middle strip. So this is the way how to redistribute negative as well as positive bending moment in the transverse direction, so that we are able to calculate that for what amount of movement, bending moment, column strip will be designed as well as half middle strip will be designed. And for all these details, to understand it more clearly, you can refer clause number 31.5.5. Okay. Now, step number 3, shear. Now, we have to design the flat slab to take care of shear stresses. So, shear in flat slabs. So, first of all, as per code guideline, we have to discuss referring clause number 31.6. What is the critical section for shear force? That means in the flat slab, and flat slab may be supported directly on column, or column may have column head or drop panel. So depending upon the availability or requirement of the design, first of all we have to locate the location of critical section. That means where the slab will be critical to the shear, so that after getting that information, that means the location of the critical section, then we can work out shear force at that section, and accordingly we can apply the checks as recommended by IS 456. Now, as per clause number 31.6, the critical section for shear shall be at a distance d by 2. Here d is effective depth. D by 2 from the periphery of the column, capital or drop panel, whatever be the case, and perpendicular to the plane of slab, where d is the effective depth of the section. Now, first of all, we have to note down that we want to get the information about the critical section for shear, which is at a distance d by 2. So we will be calculating distance d by 2 from the effective depth we have already taken in the previous steps, and from that effective depth, 50% of effective depth, and from the periphery of the column we have to locate the critical section, which is in perpendicular direction to the plane of slab. In general, plane of slab will be horizontal, so critical section will be in the vertical direction. Now we can understand here. So if this type of slab we have to design, that means this is slab and drop panel and column, then from the periphery, this will be the periphery. So from periphery of the column or drop or capital, whatever we, at a distance d by 2, we have located the critical section. So this is a vertical section. This will be the plane of the slab in the horizontal direction. So here at this section we have to calculate the shear force. Now how to calculate shear force? Clause number 31.6 is mentioned in IS 456. So when you see from the top view, that means a sectional view, if you see, this is the column which is inside a rectangle is column, whether it is a rectangular column or whether it is a square column accordingly. And from the periphery of this column or drop or panel drop, we will be locating this dotted will be the critical section. So this critical section can be shown like this from the all sides by a distance d by 2. So this is column section, it may be column or column head already explained, and this dotted will be the critical section which we are showing here also. So next step is to calculate shear stress as per clause 31.6.2. Now first of all we will be calculating nominal shear stress, and formula is given tau V is equal to V upon V naught D. V is the shear force at that critical cross section and D is the effective depth. Now shear force due to design load at that section, at that critical section. V naught is the periphery of the critical section. So V naught will be the total length of the periphery of the critical section, and D is the effective depth. Now after calculating tau V, we have to check for the permissible shear stress as limited by IS 456. So IS 456 has limited permissible shear stress Ks tau C. Now how to calculate this Ks? Formula is given, Ks is equal to 0.5 plus beta C. You have to calculate Ks by putting this value, but it should be clearly remembered and keep in mind that this Ks value after calculation should not be greater than 1. Now what is beta C? Beta C is the ratio of shorter side to long side of the column. Now in this case, because it is a rectangular column, that means one side will be shorter and other side will be longer side. But if it is a square column, then definitely beta C will be 1. In that case, Ks will become 1.5. So we will be taking the value K. So it should not be more than. So maximum value of Ks is restricted is equal to 1. And tau C. To calculate tau C, we have to use this formula. That means this tau C is the shear stress taking capacity of the concrete. That means concrete will be able to take care of shear stresses. So by this formula 0.25 square root of FCK, we will be able to calculate tau C. Tau V we have already calculated, and tau C we have calculated by this formula. Then we will be able to calculate permissible shear stress. Now if this shear stress tau C is greater than tau V, then we have to not require any type of shear reinforcement. No shear reinforcement is required. If tau C is more than tau V, it means concrete itself is able to carry or take care of all the shearing stresses. But if tau V is greater than tau C but less than 1.5 tau C, then shear reinforcement according to the guideline mentioned in the IS 456, we have to design the shear reinforcement. Otherwise mean if both the conditions are not fulfilled, that means if your tau B is more than 1.5 tau C, then the section need to be redesigned. So this is the way where according to the IS 456 we have to check the flat slab for critical shear force and stress, whether it is able to carry stress its on self. That means if the concrete in the section is able to carry or counter the shear stress, or whether it is not able to carry, then whether we have to design the shear reinforcement or we have to redesign the section. Now for more detail for different type of conditions, we have to refer figure number 13 and figure number 14 of IS 456 for details as per the requirement of the design detail. If it is a simple case, then we can go through this check. If other information is also available, then you have to minutely take care of guideline mentioned in figure number 13 and figure number 14. So this will be the figure number 13. First case we have discussed, and in second case, if there is a circular type of column, then you have to find out critical section accordingly. And figure number 13, C and D, critical section in plan for shear in flat slab. That means if there is a support section like this, then you have to accordingly find out the critical section, and the rest the formula will be same. Similarly, another condition, if there is any cutting, then critical section you can find out. And figure number 14, if that type of case happen, effect of free edge on critical section for shear. If there is a free edge, and what will be the effect of that that free edge on the critical section for shear? So depending upon the variability of the different type of problem, accordingly we have to take help of figure number 13 and figure number 14 to calculate what will be the periphery of the critical section, where will be the critical section, and how to we have to solve it. Now here in figure number 14a, here is the free edge. If free edge is there, then what will be the critical section? If the column is located at a corner, at a free corner, that means there is no extension, then you have to take critical section like this. So all the details are clearly mentioned in code along with some diagrams to understand effectively and clearly about the critical section and how to design the flat slab to take care of shear stresses. So in next class or in next lecture, lecture number 11, we will be going through a design problem. That means whatever the methodology and guideline we have covered in lecture number 9 and lecture number 10, all the guidelines, or based on all these guidelines, we will be designing a flat slab. So it is advised to all of you, go through lecture number 9 and lecture number 10 very carefully, and while going through the lecture you must keep with you IS 456, and any standard book can be referred. In my lecture I have taken information as well as diagram from reinforced concrete design book of Pillai and Menon. So you can refer Pillai and Menon to understand it more clearly, as well as with the help of IS 456. So it is my sincere advice to all of you, go through all the information in lecture number 9, lecture number 10, IS code and any standard book carefully, so that you will not find any difficulty in the design process of flat slab. Thank you. Good luck.